All right, let's jump right in. Today, we are totally unlocking the examiner's secret blueprint for Cambridge IGCSE additional mathematics, and we're zeroing in on an absolutely crucial topic, composite functions. We're going to look straight under the hood at what exactly separates your standard, everyday responses from those top-tier A-star performances. And we're pulling this directly from the examiner reports, so you're getting the exact framework for success.
So let's tackle the biggest trap out there, the one that literally separates a B grade from an A star. Does f of x always equal g of x? Well, the most common pitfall we see is students just assuming the order of composite functions doesn't really matter. But guys, in additional math, order is everything. Think about it like putting on your socks and shoes. Obviously, the order you do that in completely changes the result, right? Mathematically, it's the same deal. If function f means double a number and function g means add 1, doing g and then f means you add 1 and then you double it. That gives you a wildly different result than if you doubled it first and then added 1. Applying g then f is almost always going to give you a completely different mathematical outcome than f then g. No way around it.
So here is our game plan to get you those top marks. We're going to start by identifying that core misconception. Then we'll move into the method mark strategy, look at some huge warnings straight from the examiners, and finally build out your foolproof exam strategy blueprint. Okay, let's start with the real theoretical architecture of composite functions, where precision and really understanding cause and effect is literally everything. This right here brilliantly shows the difference in how students approach this. You've got the rushed candidate who just blindly assumes fg equals gf, basically treating function composition like it's simple multiplication. Big mistake. Then you have the strategic candidate. They actually understand that the inner function acts as the starting input for the outer function. So one candidate falls for this superficial guesswork, while the top scorer uses systematic, careful analysis to actually prove that fg doesn't necessarily equal gf. The whole assessment framework here absolutely demands logical, structured reasoning. That means prioritizing analytical depth over just superficial breadth. You can't just skip ahead and jump straight to a final answer. You have to systematically evaluate the functions you're given and justify your working, step by step, to show the examiner exactly how those nested functions are interacting. Which perfectly brings us to how this all builds into the method mark strategy, because honestly, your procedural framework is just as important as the final answer itself. So here's the absolute kicker. Examiners literally hand out marks for your process. They're actively looking to see if you are strictly following conventions. Are you using the correct mathematical formats? Are you using the right terminology, proper headings, clear step-by-step annotation? If you're substituting one algebraic expression into another to figure out fg of x, explicitly write that step out. Do not try to do the heavy lifting in your head, because you won't get the points for it. Now, what's really fascinating here is this direct insight from the principal examiners. They've explicitly stated that integrating composite functions with other areas of the syllabus is your absolute golden ticket to getting an A star. These functions, they don't just exist in a vacuum. Tying them into domain and range restrictions, or maybe quadratic inequalities, shows a true mastery of the subject. So whenever you see a composite function question, you should immediately be asking yourself, what other math concepts are hiding in this problem? Having nailed down the right methodology, we really need to look at the specific danger zones, the pitfalls identified in recent reports, so you can make sure you avoid them entirely. Examiners are consistently waving red flags about these three massive mistakes. First off, answers being way too vague. Examiners demand specific, mathematically sound details, period. Second, students are just forgetting to double-check their format and presentation, which completely throws away those vital method marks we just talked about. And third, the final answers totally lack any connection to the actual context of the question. If a problem involves real-world modeling or there are specific domain constraints for your function, your final answer has to reflect those exact parameters. And it doesn't stop there. The reports highlight a massive, critical alert. Candidates constantly mix up key terminology. You've got to explicitly define your terms and understand exactly what the notation is actually asking of you before you even start calculating. I mean, if you mix up the notation for an inverse function with a composite function, that's going to completely derail your entire response from the very first step. All right, let's take all of this examiner data and synthesize it into a highly actionable strategy blueprint for your next exam. Let's secure that A star. To really lock this in your brain, use a memory hack like the acronym OMFA. It's designed to help you instantly recall the strict rules for composite functions the second you turn that exam page. O stands for order, reminding you that FG does not necessarily equal GF. M is for method, always show your step-by-step process. F is format, make sure you're laying out your algebra logically. And A is annotation, meaning you are explicitly communicating what you're doing clearly to the examiner. You see, top-scoring candidates don't just calculate, they demonstrate evaluative thinking. They're constantly identifying mathematical limitations, questioning assumptions, considering alternative interpretations, and justifying literally every single step with hard evidence. For example, if figuring out a composite function leaves you with a denominator that could potentially be 0, you absolutely must state that limitation in the domain. That is exactly what true analytical depth looks like in the real world. So, I'm going to leave you with this final thought to ponder while you study. If order is absolutely everything in composite functions, and changing that sequence completely alters the final outcome, how are you going to transform your working habits today to absolutely guarantee you get those critical method marks tomorrow?